Okay, so we are on the third part of section 2.3. I know this is a long section, but the hardest part is over. The second video, in my opinion, is the hardest one. Okay, so here's some definitions that we've already looked at. Let's just go back over them. A function is a relation in which for each value of the first component, x, there is exactly one value of the second component, y. A function is a set of ordered pairs in which no first component is repeated. We talked about that. X is not repeated. A function is a rule or correspondence that assigns exactly one range value to each distinct domain value. Now here's function notation. When a function f is defined with a rule or an equation using x and y for the independent and dependent variables, we say y is a function of x. To emphasize that y depends on x, we use this function notation, y equals f of x, called function notation. And like I just read it, it's f of x. This is not f times x, this is f of x. So note that f of x is just another name for the dependent variable. Y. The symbol f of x does not indicate f times x, but represents the y value for the indicated x value. Now, I think y'all are going to like this. This is pretty easy. All we want to do here is using this f and this g as they have defined it, we want to find and simplify each of these. So let's do f of 2 first. Remember, this is f of x. So that means I want to replace x with 2. Everywhere I see an x in f, I want to put a 2. F of 2 equals, now be careful here, this is not negative x in parentheses. This is negative 2 squared plus 5 times 2 minus 3. This is not negative 2 squared because there's no parentheses here. This is like negative and then 2 squared. So 2 squared is 4. This is negative 4 plus 10 minus 3. Negative 4 plus 10 is 6. 6 minus 3 is 3. So f of 2 is 3. Just to clarify, this is x, this is y. F of x equals y. So when x is 2 in the function f, y is 3. Okay, that's what that means. Anytime you are asked to find f of a number, your answer should be a number. Your variables should be gone. This, however, we're finding f of a variable, so we should have variables in our answer. All they're wanting me to do is replace x with q. So f of q equals negative q squared plus 5q minus 3. Now, since I don't know what q is, I can't simplify this any further. That's the answer. In C, they're wanting us to put a plus 1 in place of x in G. So everywhere I see an x, I want to put a plus 1. Well, that's going to be, hold on, let me come down. I don't think I'm going to have enough room. So G of a plus 1, put an a plus 1 here where you see this x in G. So 2 times a plus 1, and then plus 3. So G of a plus 1 equals distribute to a plus 2 plus 3. Combine these like terms, 2a plus 5. Again, if you're finding f or g of something that has a variable in it, then you should have variables in your answer. But if you're finding f of a number, your answer should just be a number. Okay? We're still finding f of a number, but we want to use these different types of relations. Here's the same thing we just did. Put 3 in wherever we see an x. F of 3 equals 3 times 3 minus 7. 9 minus 7, 2. So that's what we just did. Now let's find F of 3 here. F of 3. Okay, well this one's a little different. We don't see any x's that we're plugging in. But I know x is 3. This is my position for x. So go to your ordered pairs until you find the x value of 3. Since f of x equals y, we're looking for the y value that goes when x is 3. So when x is 3, y is 1. So that's our answer. This is x, this is y. So f of 3 equals 1. Same thing here. F of 3, find 3 in your x's. Here is 3 under my x's. 3 is being mapped to 5. Therefore, 5 is the answer. Here, I'm still trying to find f of 3. 3 is my x, so I go on my x-axis till I get to 3. Go up to your line. Now I need to figure out what is this y value. That y value is 4. So that is f of 3. Okay? Now, sometimes you're going to be asked to find an expression for f of x. To find an expression, you have two steps. One, you want to solve your equation for y. Then you want to replace y with the function notation f of x. So let's do that in example 8. Assume that y is a function f of x. Write each equation using function notation, then find f of -2 and f of a. So the first thing I want to do is rewrite it using function notation. Solve for y, replace y with f of x. Well, this one's already solved for y for us. So step 1 is done. Step 2, replace y with f of x. That's all you're doing. Once you have y equals, change y to f of x. So there's the first part. We're done. Now they want us to find f of -2. Okay, so plug in -2 where I see an x. This time we are squaring -2. So that's +4 plus 1, which is 5. Okay? Oh, and we need to do f of a, sorry. All they want us to do here is replace x with a. A squared plus 1. And that one's done. Here I need to first solve for y. That's not done for us. Don't plug anything in. Leave x as x. Leave y as y. So all I'm going to do is move my x over, and it becomes 5 minus x. To get y by itself, we divide by -4. So y equals 5 minus x over -4. Now, you need to know that there's several different ways to write this. You could just leave it like this. You could move the negative to the top, which would make this -5 plus x over a +4. Or you could break this up into two fractions. I'm just going to leave it like that. So step 1 is done. Solve for y. Step 2 is replace y with f of x. So there's the first part. Now they want us to find f of -2. That means put -2 where I see an x. So 5 minus a -2 over -4. 5 plus 2 is 7 over -4. Okay? Then they want us to find f of a. All they're doing is replacing x with a. So 5 minus a over -4. Okay, last example. I know this is a long section. Just bear with me. Increasing, decreasing, and constant functions. Now, this wording is a little confusing, so let me just tell you this. first of all, always read your graph left to right. F is increasing if your graph goes up from left to right. Your function is decreasing if it goes down from left to right. It is constant if it is a horizontal line. So looking left to right, if it goes up, it's increasing. If it goes down, it's decreasing. If it's horizontal, it's constant. They want us to determine intervals over which it is increasing, decreasing, or constant. Now, notice it says intervals. You need to know that it's talking about intervals over the domain. It doesn't say that, but you need to know that we're talking about intervals over the domain. So in other words, we're only looking at the x values. So when I write intervals, I'm talking about the x values. This first function here, left to right, it is going down. Therefore, it is decreasing. So the first part is decreasing. And it is decreasing from negative infinity, because on the x-axis, this goes out forever, negative infinity, and it stops at x value of 1. Since I have an open hole there, that is a parentheses. If you have a closed circle, then it's going to be a bracket. Open circle, parentheses. Okay? This next little piece is going up from left to right, so that is increasing. It's increasing from the x value of 1 to the x value of 3. Both closed circles, so brackets from 1 to 3. This next piece is horizontal line, so that's constant. Again, it starts at x equal 3 and goes to x equal infinity. So it's constant from 3 to positive infinity. Now there are lots of exercises here, but remember we did 9 examples. So go try exercises 9, 11, 17, 19, 23, 35, 37, 43, 67, 77, and 79 from your ebook. Some of these are just real fast. Is it a function? Check your answers. If you can't get the right answer, see one of the math instructors and they'll be happy to help you with this. This concludes section 2.3.